Hello everyone, welcome back to another video. Today we're going to be looking at the KZN June 2024 exam, specifically the vertical projectile motion question. If you'd like to give it a go, please pause the video. I will do the answers in 3, 2, 1. Okay, let's look at the question. Question number 3. Two learners are practicing target shooting. One learner throws a tennis ball vertically upward at 30 meters per second from the ground. So what I'll do is, while it's still in my memory, we'll write down tennis ball. And I will choose a direction as positive. I'm choosing up as positive. And the initial velocity I'm going to write down as 30. When the tennis ball reaches a maximum height above the ground, the other learner throws a stone toward the tennis ball. So a stone. The stone hits the tennis ball 5.2 seconds later. The graphs of position versus time for part of the motion of both the stone and the tennis ball are shown below. Ignore the effects of air friction. Okay. So 3.1, define free fall. Again, definitions, you have them, so I won't waste time. Question 3.2, which graph S or T represents the motion of the stone? Now, funny enough, this is an error in the question because they haven't labeled the graphs for us. But what I will do is I've already highlighted tennis ball in yellow and stone in green. So what we'll do now is we will highlight the graph that would represent the tennis ball and the graph that would represent the stone. So the tennis ball was thrown first. So it's in air for the longer period of time. So the graph that shows an object for the longer period of time is this one. So that would be the tennis ball. And that means this was going to be the stone. Okay. Calculate the time Tx shown on the graph. So what is Tx? So if you look here, Tx is this. Tx is the time at which the stone was thrown, right? It's also the time where its max height for the tennis ball, right? Now, what's the one thing we know about max height? We know at max height, the Vf is 0. So we can work that out. So let's number this question 3.3. We know the Vf is going to be equal to 0. And I know that acceleration is going to be minus 9,8. Now, for this section, if you know 3 quantities, then you're good to go. You know that you have enough information to calculate anything. Okay? So what we'll do now is we'll choose an appropriate equation and then we'll work out the time. So if we want time, we will use the first equation. And the equations are in your data sheet. So Vf is equal to Vi plus A delta T. 0 is equal to 30 plus minus 9,8 delta T. Then delta T is equal to 3,06 seconds. So in other words, this time here, that's 3,06 seconds. So after 3.06 seconds, the stone is thrown. You could also interpret it like this. After 3.06 seconds, the tennis ball reached maximum height. Okay. Next, calculate the velocity with which the stone was thrown. Okay. Now, if you look at the mark scheme, 6 marks. Don't panic. For a 6-mark question in physics, it's either going to be simultaneous or you're going to have multiple equations that you need to use. All right. Now, let's try to look for some commonality between the two. Okay, what do we know is going to be the same for both of those objects, the tennis ball and the stone? Okay, now remember, you have to think of it in the terms of this scenario. The tennis ball is thrown up and then the stone is thrown and they hit each other in the air. So it means that the height above the ground that both of them are at 5.2 seconds is going to be the same. So this height here, see, they hit each other here. So this height, whatever that height is going to be the same for both of them, right? Now we can work out what that height is going to be because we can use the tennis ball because we have enough information, okay? So let me just number here, question 3.4. Now for the tennis ball, again, VI is 30. We don't know the VF. We know A is minus 9,8, but we know the time that it's in the air for. It's in the air for 5.2 seconds. 5.2. So if we want to work out the height above the ground, in other words, the delta y, we can say VI delta t plus half A delta t squared. So we can substitute 30 times 5,2 plus half minus 9,8 and then 5,2 squared. And if you put that in our calculator, we'll get an answer of 23.5. So 23.50 meters. So that's that height. That's the height here. This is 23.50 meters. Right? Now let's redirect, because remember we want information about the stone. So let's look at the stone now. Right? We know that the stone is going to reach a height of 23,5. Right? We know that the acceleration is minus 9,8. Now we also need to consider the time. Now we can work out the time. Because remember, the time for the stone is from here to here. So if you want to work out what is the time from there to there, that time is going to be 5,2 minus 3,06. So the time that it ended minus the time that it started. And that is 2,14. So the stone is in the air for 2,14 seconds. So delta t is 2,14. Now we can use the same equation to work out the initial velocity. We'll say, so we'll use the same equation here. We will say 23,5 equals VI times 2,14 plus half minus 9,8 and then 2,14 squared. Running out of space, but now you solve for VI. And when you solve for VI, you get an answer of 21,47 meters per second upward. Okay, so that's the answer for question 3.4. So in this case, we didn't need to do a simultaneous equation, but we needed to do two separate calculations. Right, question 3.5. On the same set of axes, sketch a velocity versus time graph for the motion of both the stone and the tennis ball until the stone hits the tennis ball. Indicate the following: the initial velocities of both, the time at which the stone was fired, the time taken at which the stone hits the tennis ball. Okay, it's not too bad. So what I've done here is I've just sketched out a graph for us here. Now, let's look at the information that we know. So we know the tennis ball, the VI was 30. We know that after 3.06 seconds, the V was 0. And we know that it hit the stone at 5.2 seconds. So how would this look? So initially, VI is 30, so the graph would start here. Then after 3.06 seconds, so I'm going to estimate it being somewhere there, the velocity is 0. So the graph will go something like this. Oh, that line is a bit crooked. Let me try again. Okay, of course you use a ruler, but I hope you get the idea. So 5.2, roughly 5.2 is somewhere there, right? So this is going to represent the tennis ball. Now, if we have to consider the stone, the velocity of the stone, we worked it out as 21,47. So 21,47, estimate somewhere here, but it doesn't start there. Remember, it's only thrown after 3.06 seconds. So it starts here. And then it will hit the tennis ball also at 5.2. So the graph will go like this, somewhat like this. Now, be careful here, because we can't let this graph, the one that I've just drawn, we can't let it touch the x-axis. And the reason is because we can't say for sure if this, whether this point is max height. Now we can calculate that, but it's not necessary right now. So just to be safe, we'll draw the graph like this. And also, these lines that we drew should be more or less parallel to each other. And that's our answer. So that's the VPM for this paper. If you found this helpful, then please consider leaving a like, subscribing. If you'd like me to do a specific paper, please let me know down in the comments. I'll see you in the next one.